Welcome to 11.5, and we are looking at exploring solids. So what's that talking about? Well, how do I identify solids in particular is what we're looking at, but solids are these three-dimensional figures, and so finally we're able to get out of just the two-dimensional boring stuff, and so put on your three-dimensional goggles and let's get to town. In order to do this, let's identify, first of all, some useful terminology. Polyhedron. Poly is many, hedron is faces. So a polyhedron is a three-dimensional object that is a solid that has many faces, and these faces are polygons. So polygons, you will remember, are a closed figure with straight sides. So for example, this is a polygon right here, and so we call this a face. And a polygon, or I'm sorry, a polyhedron is a solid or three-dimensional figure that is bounded by all polygons. And so you see here, each of these going all the way around are polygons, and so therefore this is a polyhedron. Polyhedron. Let's talk some more about this polyhedron and identify some terms for different features of this polyhedron. Edge, pretty simple, is the edge of the solid where it comes to a sharp line here. And then vertex is where it comes to a sharp point. We're familiar with that term, but it's a unique term now for us, where in a three-dimensional it's not only where two lines are connecting, it's actually three different lines are connecting together, intersecting, or concurrent, there it is, concurrent with one another and creating this vertex. Okay, and the reason that the term polyhedron is helpful for us is because we do have solids that are not polyhedron, or that are not a polyhedron. So polyhedron is a singular, one polyhedron, and polyhedra are more than one polyhedron. So on the left hand side here, these two guys are polyhedron. Each of these are a polyhedron. Whereas on the right hand side, these two are not polyhedrons. You are familiar with these terms, I believe. Prism, cylinder, pyramid, cone, and sphere. Those are our five different three-dimensional solids that we're going to be focusing on, that we need to be able to differentiate between these five different shapes. So we've already identified that on the left hand side, a prism and a pyramid, those are polyhedra. In other words, each of these, this is a polyhedron, a prism is a polyhedron, and a pyramid is a polyhedron. Why? Because each of these surfaces are polygons. Right? Polyhedron means each of the surfaces are a polygon, and we call those surfaces faces. Okay, we got that. And again, these over here, the cylinder and the cone, are not polyhedra. A cylinder is not a polyhedron. Why is that? Because the surfaces are not polygons. This is a circle. A circle is not a polygon. Remember, the definition for polygon is it's a closed figure. So a circle is a closed figure, but a polygon is a closed figure with straight sides. And obviously in a circle, this is not a straight side. And then same thing also with a cone. A cone is a solid, yes, but it is not a polyhedron because these are not straight sides around the cone there. So prisms and pyramids are polygons, but a cylinder and a cone are not. I said polygons, didn't I? I meant polyhedrons. Prism and pyramids are polyhedrons, or polyhedra is a better term, and cylinder and cone are not polyhedra. And of course also a sphere is not a polyhedron. So let's look now at differentiating. Let's just focus on prisms and pyramids. So what's the difference between a prism and a pyramid? Well, the main identifying difference is that a prism has two bases. Prism has two bases, and a pyramid only has one base. And let's define what we mean by base. So base means that, well, actually, no. In order to identify two bases, let me say it that way. In order for there to be two bases, those two bases have to be congruent and parallel. In order to be bases, they have to be congruent and parallel. So notice here that these two rectangles on the bottom and also up on the top, those are congruent. These two shapes are congruent, and those two shapes are parallel. Whereas for a pyramid, there's only one base here. There is not another base that is congruent and parallel to it, because everything is pushed up into what we call the apex. This is a vertex, yes, but it is a unique vertex. It is a gathering, I might say, of the base sides, or all the sides brought up into one vertex, and that is called your apex. Notice also that for a prism, each of these faces going around the bases are rectangles, whereas for a pyramid, these faces are triangles. Each of these triangles are coming up to your apex. Okay, so prisms have two bases, and the faces are rectangles. Pyramids only have one base, and the faces are triangles. Let's look now at cylinder and cone. These are actually a little bit easier to identify. Maybe I should have started with this one. But notice that a cylinder has two bases, and these two bases are congruent and parallel with each other, whereas a cone only has one base, and the sides are pulled up into that apex. And then a sphere has no sides to it. It's all, or maybe, I guess you could call it one side, but we definitely do not call it a face. A face has to be a polygon, a closed figure with straight sides. And so a sphere just doesn't fit into that at all. All right, let's look at identifying these polygons. Where am I? Over here. Here we go. And polyhedrons. I keep on saying polygon, don't I? But polyhedron is what I want to say. And actually, we need to identify whether or not it is a polyhedron. So these are just solids. Let's start out there. These are just solids. And we have to identify whether or not this is a polyhedron, and then what kind of polyhedron it is. So I'm looking here, and we can choose this as a base, this rectangle, and then there's another rectangle that's on top of it, and it appears that these guys are parallel and congruent, so it has two bases. You know what, I probably should have began with looking at each of these sides and confirming that each of these sides are indeed polygons. And since they are polygons, therefore we can call them faces. So these are all these surfaces are faces. And then we found two faces, that are congruent and parallel. So let's call those faces bases. So there's a base on the bottom and there's a base up on the top here. And because we have two bases, therefore this is going to be a prism. And what kind of prism is this? Well, the identifier for a prism is based on what kind of base. What is the base? And this base is a rectangle, and so therefore this is a rectangular prism. Let's look over here at this dude, and first of all let's identify the sides, or the surfaces, let's call it that way. And are these surfaces polygons? And on the bottom here it looks like we have a, what is this, 1, 2, 3, so that's a hexagon. And then on the sides, these are all triangles. Yep, so all these are polygons, all these surfaces are polygons. Therefore, this is a polyhedron. This is a polyhedron. Okay, so what kind of polyhedron is it? And it has only one base, and all the rest of the sides, side surfaces, are triangles, and so therefore this is an apex, and this entire thing is called a prism. Oh, I messed it up, didn't I? A pyramid. So this is a pyramid. Only has one base, so therefore it is a pyramid. Next one here. Let's look at the surfaces. And are these surfaces polygons? And the answer is no. This circle definitely is not a polygon, so therefore this is not a polyhedron. And so therefore what kind of shape is it? Well, it does have a base. It does have a base, so but only has one base, so therefore this guy is a cone. A cone and a pyramid only have one base. Okay, you are ready now to be able to tell whether or not each of these solids is a polyhedron. Remember, polyhedron means it has to have each of the faces, or each of the sides, surfaces, each of the surfaces are polygons. And then name that, if it is a polyhedron, then name that polyhedron, and then find the number of faces and vertices and edges. So identify the number of, let me give you, F means faces, V means vertices, and E means edges. So go ahead and identify the solid that it is, and then tell me the number of faces, vertices, and edges that each of these guys have. Okay, go ahead and pause the video and do that. Let's look over on the back side of your notes now, and we're going to look at this theorem that was discovered by Euler. I think is how you pronounce his name. So Euler's theorem, and his theorem was that you can count up on any polyhedron, has to be a polyhedron, you can count up the number of faces and the number of vertices and add them together, and that will always equal the number of edges plus 2. So for example, here we have a solid, and let's look first at all the surfaces, and yep, all these guys are polygons, so this is a polyhedron. Remember, Euler's theorem only applies to polyhedrons. And now what kind of a polyhedron is it? Well, we have two bases. We have each of these faces, yes, but we have two faces that are congruent and parallel. And so therefore this is a prism. And let's count up the number of faces that are on this prism. You can think of it, this pink here, face that I emphasized, is actually in the back. So it's like invisible. You would not be able to see it if you were to take, this is way too big though, huh? If you were to take a prism like this, notice that you are not able to see the back side here. but we're drawing it in such a way that allows us to be able to visualize it. And notice that these are dashed lines, so therefore we make them dashed to indicate that we cannot normally see them. So this is the front side right here, and the pink is your back face. So if you were to count the number of faces, you go 4 around the sides, and then you have your 2 bases. That gives us 6. And then vertices, how many vertices do I have? I've made those green here. I count 4 on the base, and then there's 4 on the top base. That gives a total of 8. And then edges, you can count, you can do it this different way. There's 4 edges around the base, and 4 edges around this top base, and then there are 4 edges around the sides, so a total of 12. And then if you were to add the number of faces with the number of vertices, you're going to get 14, and the number of edges plus 2 is also 14. So Euler's theorem is always true, but it's only for polyhedrons. It has to be a polyhedron. So I give you, what is it, 6 different polyhedrons here. And what I'm asking you to do is go through and tell me the number of faces. So on this, well, first of all, what kind of a solid is this? And it is a pyramid. So notice it's all coming up to a vertex. There's only one base, and all the sides here are triangular. So count the number of faces that you have. So there's one of the faces at base, and then how many faces do we have going around the side? You can count the number of sides of the base. There's 4 of them, so that gives a total number of 5 faces. And how many vertices do we have? Let's see, 1, 2, 3, 4 on the bottom, and then all these sides come up to a vertex here, which is called your apex, and so that's 5. So there are 5 vertices. And how many edges? I see 1, 2, 3, 4, 5. And why did I say 5? I see 1, 2, 3, 4 are on the bottom, and then you have 4, again another 4 around the side here. So that makes 8 edges. So add those up, put them into Euler's formula, and we're asking, is this true? I want you to confirm that Euler's formula is true. So take the number of faces plus the number of vertices, and see if that equals the number of edges plus 2. Okay, so do that for each of these. This here is a rectangular prism, and here is actually a triangular prism. And let me explain that, because you might think, hey, this is the base down here, capital B, but no, the other side, there is not another base that is parallel and congruent. And notice that the other edges here do not come up into a apex. And so actually this triangle here is a base, and also